everyone, welcome to day 2 of inverse functions. For today we are going to learn how to find the inverse of a story problem function, or a function that's derived from a story problem. And we're also going to learn how to determine whether the inverse of a function is also a function. And we're going to be using the horizontal line test to help us do that. But before we get started, I would like you to please go ahead and complete this really quick warm-up. It reads, if f of x is equal to 4x plus 1 and g of x is equal to the square root of x minus 1 plus 1, find f of g of x and g of f of x. So please go ahead and pause the video and try this problem. And when you're ready, go ahead and restart the video to see how well you did. All right, so we're going to substitute g of x into our f of x function. G of x is the square root of x minus 1 plus 1. So I'm going to rewrite this as f of the square root of x minus 1 plus 1. So I'm going to substitute this entire function in for x into my f function. So this is going to be 4 times the square root of x minus 1 plus a 1 on the outside. Now I'm going to distribute that 4 to each term. And I have 4 times the square root of x minus 1 plus 4 plus 1. I'm going to combine my like terms, which is 4 plus 1, and that's 5. So my answer is 4 times the square root of x minus 1 plus 5. And that is it. That's all you need to write. Next, we have g of f of x. So that means I'm going to substitute the entire function for f of x, which is 4x plus 1, into my g function. So I'm going to replace x with the entire f of x function. So that's going to be g of 4x plus 1 is equal to the square root of 4x plus 1. Then I'm going to write minus 1, then a plus 1 on the outside. Combining my like terms, 1 minus 1 is 0, so that goes away, and I'm left with the square root of 4x plus 1. Since the main operation under the root is multiplication, I can take the square root of each piece. The square root of 4 is 2, and then I have the x right here. I can't take the square root of x, so I'm just going to leave that inside of the root. So that's 2 times the square root of x plus 1. And that is your answer. There's nothing further for you to do. So hopefully you did pretty well on the warm-up. If you have any questions on it, please feel free to email me. This is something that is not going away. It will certainly be on your final exam, and there might be some questions like this on your test that's going to be coming up. So here we go. Our objective for today is to be able to use solve story problems using inverses and identify the inverses of those functions. And I want you guys to be able to use the horizontal line test to determine whether a function's inverse is also a function. So that's what our goal for today is. So the first thing that we have here is a small company produces greeting cards. The cost C in dollars of producing N greeting cards. So we have cost that's C, and we're producing N greeting cards per month, can be modeled by the function C is equal to 360 plus 0.6 N. Now, the first thing we want to do is find the inverse of the model. In order for you to find the inverse of the model, we do not switch the variables. And that's because the variables have meaning. So in order for us to find the inverse, it's essentially finding the reverse of the problem. So we're going to solve for the other variable. So we do not switch the variables, we just solve for the other variable. And that only happens whenever we're working with context. If we're not working with context, then that's when you switch your x and your y values. In this case though, we're starting off with C is equal to 360 plus 0.6 N. So what we want to do here is simply solve for N. So I'm going to start off by subtracting 360 on both sides. And we end up with C minus 360 is equal to 0.6 N. Well, that 0.6 N is kind of awkward. So it might be helpful and beneficial to change the 0.6 to a fraction. So what does 0.6 mean? Well, that means 6/10. So 6/10 can be reduced to 3/5. So this really means C minus 360 is equal to 3/5 n. So I'm just rewriting that problem, changing the decimal to be a fraction. So now I'm going to get rid of that fraction by multiplying both sides by the reciprocal. And I'm going to make sure I use parentheses because I'm multiplying both entire sides by the reciprocal. The 3/5 and the 5/3 cancel away, and we're left with, if I distribute to each term, we have 5/3 C minus 500 times 360, and take that number and divide it by 3, you'll end up with 600. So that's going to be equal to n. So now we're going to use this function, so it says use the inverse function, to find the number of greeting cards. So we want to find n. Number of greeting cards produced in a month in which the company's total cost to produce the cards was $615. So we're going to use 5/3 C minus 600 is equal to n, and we're going to let C equal 615. So I'm going to write 5/3 times 615 minus 600, and that's going to be equal to the number of greeting cards. Because we're dealing with all numbers here, you can simply put this entire expression into your calculator exactly as you see it. Please make sure, though, that you use parentheses around the 5/3. So we enter it into our calculator exactly as we see it. Press enter, and we end up with 425. So 425 is equal to n. So what that means is that it will cost the company $615 to produce 425 greeting cards. And that is your answer in context. All right, let's go ahead and flip the page. Now, the next question says, the population of a town can be modeled by P is equal to 16,500 times T to the 0.15 power. That's where T is the number of years since 1998. We want to find the inverse model that gives the number of years as a function of the population. So what that means is solve for T. So if we're starting with P is equal to 16,500 times T to the, well, just like before, working with the decimals, exponents are kind of weird. It might be in our best interest to change it to a fraction. So what does 0.15 mean? Well, 0.15 means 15 hundredths. So that means 15 out of 100. Both 15 and 100 have a 5 in common. So if I divided 5 in the numerator and the denominator, I'd end up with 3/20. So I'm going to rewrite this as P is equal to 16,500 times T to the 3/20 power. Why I changed the exponent? Well, that's because it's a lot easier to get rid of an exponent when it's a fraction instead of when it's a decimal. So now my goal is to get T alone. So I'm going to start off by dividing both sides by 16,500. So I have P over 16,500 is equal to T to the 3/20 power. So the way to get rid of 3/20 is to raise both sides to the reciprocal power. So the reciprocal of 3/20 is 20/3. So I'm going to raise both sides to the 20/3 power. So now I have P over 16,500 raised to the 20/3 power, and that's going to be equal to, well, if I multiply it straight across, I have 60/60, which is just 1. So this is T to the first power, or just T. And that's our inverse function. So now we're going to use this inverse function of T is equal to P divided by 16,500 raised to the 20/3 power. And we're going to use this model to predict the year in which the population of the town will reach 25,000. So that means that we're going to let, if we have the population equaling 25,000, we're going to let P equal 25,000. So I'm going to write T is equal to 25,000 divided by 16,500, and that's going to be raised to the 20 over 3 power. And you can put that into your calculator exactly as you see it, but I would recommend putting that 20 over 3 power into parentheses depending on the type of calculator that you have. So I'm going to go 25,000 divided by 16,500, and that's going to be raised to the parentheses 20 divided by 3 power. And so that's about 16. So since we're talking about full years, I'm going to round that to the nearest whole. So that's about 16. So T is approximately 16. But what does that mean? Well, T is the number of years since 1998. So we're talking about 16 years since 1998. So what I'm going to do is I'm going to take 1998 and I'm going to add 16. And 1998 plus 16 is 2014. Excuse me. So what does 2014 mean? It means in 2014, the population should reach 25,000. And that's our answer. So now that's the first part of our lesson. The second part of our lesson deals with graphs. So there's going to be different types of functions that we're going to be graphing. We're going to be graphing linear functions, absolute value functions, quadratic functions, cubic functions, and then parts of quadratic functions. So we have 5 functions that we're going to have. You might want to have a calculator out for this portion of the lesson, and you might want to have a straight edge out for this portion of the lesson, because we will be graphing. We're going to be using old skills that we've used in the past, things that are going to be coming back that you'll need to make sure that you remember how to do. So I would make sure that you study your Chapter 5 and your Chapter 4 notes for this lesson and for this section. So the horizontal line test. You can use the graph of a function f to determine whether the inverse. So we're going to use the graph of a given function to determine whether the inverse of f is also a function by applying the horizontal line test. So what the horizontal line test says is that the inverse of a function is also a function if and only if no horizontal line intersects the graph more than once. So in this case, I can take this horizontal line and raise it up and down, and it will only cross at one point at a time on this function. This function right here is an odd function. Just look at the end behavior. So for this odd function, the inverse is a function. Why? Because it passes the horizontal line test. So whenever we're graphing inverses, we learned in the last lesson that the graph of the inverse is always a reflection across the line y equals x, where the x and y values of the function are essentially switched or flipped. So the inverse is like switching or flipping your x and y values. So your x-axis becomes the y-axis, and your y-axis becomes the x-axis. And this graph does represent a function. It passes, in this case, the vertical line test. The vertical line test says, if I can draw a vertical line that only crosses one point at a time, then it is a function. And in this case, we do have ourselves a function. Excuse me, guys. In this case, we have ourselves an even function. Just look at the end behavior. And in this even function, the inverse is not a function. And that's because there exists a horizontal line that can cross the function at more than one point. And if we were to graph a function, if I tip this graph on the side, and if we were to graph it, it would not pass the vertical line test. It wouldn't, because we would have a vertical line going through more than one point. So for even functions, we would have to restrict the domain in order for the inverse to have a function. So you need to see a restricted domain for even functions to work. So you'll have to see something like that. So what's going to happen is we're going to be graphing functions. So we're going to graph our f function. Then we're going to use the graph to determine whether the inverse of this function is also a function. So we're going to graph f of x is equal to 3x plus 1. Our y-intercept is located at 1. Our slope is equal at 3, so we're going to use 3 over 1. So I'm going to go up to 1, and I'm going to rise 3. 1, 2, 3, 1, run 1. All you need are a few points in order to draw a line. You only need 2, but I'm going to just graph a couple. And here is my line. If I were to draw a horizontal line going through any of these points, it only crosses one point at a time. So it only crosses one point at a time. So therefore, we can say the inverse of f is a function. Because it passes the horizontal line test, the HLT. Let's go ahead and look at letter B. For letter B, this is an absolute value function. The first thing you want to do whenever you graph an absolute value function is identify the vertex. The vertex is the opposite of what you see inside. So the opposite of -4 is +4. And exactly what you see outside. So that's a +2. Then the slope of the right-hand side is your A value. And that's going to be a 1. So your slope is going to be a 1. So I'm going to plot 4, 2. And I'm going to find my slope by rising 1 and running 1, coming up with a few points. And then I'm going to do the opposite on the other side. Rise 1 and run back 1. Always extend your lines across the grid. And let's look at a horizontal line. I can draw a horizontal line right here, and it crosses at more than one point. Therefore, the inverse of this function is not a function because it fails the horizontal line test. And that's what I'm going to write. The inverse of f is not a function because it fails the horizontal line test, the HLT. We have 3 more graphs and then we are finished with this lesson. Let's go ahead and flip the page. So the next one that we're going to graph is a quadratic. This is a quadratic that is written in intercept form. I'm going to give you the steps for intercept form, but you'll need to make sure that you go back to chapter 4 and make sure that you study how to graph each different type of quadratic function. That is definitely going to be on your final exam at the end of this semester. So please make sure that you go back and you study. This is from chapter 4. This is going to be a parabola. So the first thing we want to do for example number 5 is we want to graph the function Then we want to determine whether the inverse of the function is a function using the horizontal line test. Then find the inverse function only if it exists. So if it doesn't exist, we're not going to identify it. So let's go ahead and look at letter A. This is a function that's written in intercept form. So that's the first thing that we're going to identify, our x-intercepts. Our x-intercepts are located at -3 and 1. So it's just the opposite of the parentheses. So I'm going to plot the ordered pairs -3, 0, and 1, 0. So I'm going to plot 1, 2, 3. Here's -3, 0, and here's 1, 0. The next thing we want to do is identify our line of symmetry. Our line of symmetry, that's the average of your x-intercepts. So that means that you take your x-intercepts and you average them. So I'm going to add -3 plus 1 and cut it in half. -3 plus 1, that's -2, and -2 over 2 is -1. So x equals -1 is my line of symmetry. So I'm going to go to where my line of symmetry is at x equals -1, and I'm going to draw a vertical dashed line. The line of symmetry also represents our vertex x. So in terms of my vertex, I already know half of it. Now we need to find the other half. So I'm going to substitute -1 back into the original problem. So that's going to be y equals -1 plus 3 times -1 minus 1. So that's -1 plus 3 is 2. And -1 minus 1 is -2. And 2 times -2 is -4. So -1, -4 is our vertex. Next, I'm going to go ahead and identify my y-intercept. My y-intercept is located when x is equal to 0. I'll find what y is. So I'm going to write y is equal to 0 plus 3 times 0 minus 1. So that's 3 times -1, which is -3. So at 0, -3, that's my y-intercept. And I'm going to identify a reflection point by counting. This point is 1 unit away from the line of symmetry. So I'm going to count 1 unit on the other side. And that seems to be located at -2, -3. Now I'm going to draw a smooth curve going through all 5 of my points. And now I'm on to step 2. Now that I have my graph, I'm going to determine whether the inverse of this function is a function. And unfortunately, it does not pass the horizontal line test. I can draw a horizontal line at any point. And it doesn't cross necessarily one point at a time every single time. So I'm going to say this does not pass the inverse of f. Is not a function because it fails the horizontal line test. And because it fails the horizontal line test, we do not need to identify the inverse of that function because it's not a function. So let's go ahead and look at letter B. For letter B, it's a little bit easier. For these types of cubic functions, we needed to identify the end behavior, and we also needed to just identify a table of values. So my end behavior, we know that this is an odd function. It's an odd positive. And that's because our leading coefficient is positive. So that means that as x approaches positive infinity, odd positives look like this. F of x is approaching positive infinity. So as x approaches positive infinity, f of x approaches positive infinity. And as x approaches negative infinity, so that's over here, we have an arrow that is pointing down, f of x would approach negative infinity. So now the next thing we're going to do is we're going to identify a table of values. We only need a few table of values, so I'm going to choose negative values as well as positive values. So I'm going to choose -2, -1, 0, 1, and 2. Now for time purposes, I'm going to give you the y values, but what I'm doing here is I'm going to be substituting each of these x values into the function. So I would be going 4 times -2 to the third power minus 5, and that number is -37. The next one is -9. The next one is -5. Then we have -1 and 27. Please make sure that you feel comfortable with substituting numbers into a scientific calculator since this is graphing. Just putting that out there. Make sure that you feel comfortable with that. So now I'm going to graph each of these ordered pairs and only plot the points that I can. So I'm probably not going to plot -2, -37, but I know it's going to be pointing down. So I'm going to plot -1, -9. I'm going to plot -1, -9. So here's -1, -9. Then I'm going to plot 0, -5. And 1, -1. And 227 I can't plot. So it's going to be kind of like a really elongated line looking thing. Okay, let's look at our horizontal line. Clearly, a horizontal line will only cross at one point at a time. So we would say that the inverse of f is a function because it passes the horizontal line test. So now what we're going to do is we're going to actually identify what the inverse actually is. So I'm going to write f of x is equal to 4x cubed minus 5. There's no context with this problem, so that means that I'm simply going to flip-flop the x and y value. So I'm going to change f of x to be y, and I have y is equal to 4x cubed minus 5, and I'm going to switch my x and y values. So this is going to be x is equal to 4y cubed minus 5, and I'm going to solve for y. So I'm going to add 5 to both sides, and I have x plus 5 is equal to 4y cubed. I'm going to divide every single term by 4, and I have x plus 5 over 4 is equal to y cubed. In order to get rid of a cube, I'm going to take the cube root or raise it to the 1/3 power, which is a little bit easier, and that would be the actual preferred method. And so my answer is going to be x plus 5 over 4 raised to the 1/3 power is equal to my inverse function. And we always rewrite that using that inverse notation of f to the -1st power of x. We always rewrite any new y's as using inverse notation, and that is our answer. We have one last problem, and that's letter C. But notice that this time we have ourselves a quadratic with a restricted domain. That means I don't want you to be going through all of the steps that we did when we were graphing quadratics because it has a restricted domain. So that simply means that we're going to be working with a table of values that follows the domain. So my x values in this case need to be x values that are 0 and greater. So I'm going to select 0, 1, and 2. Maybe even 3, depending on what type of problem, what type of numbers I get. So when I plug 0 in, I end up getting 2. When I plug 1 in, I get 3. And when I plug 2 in, I get 6. And that should be good enough. So I'm going to plot these points. Plot 0, 2, and 1, 3, and 2, 6. And I'm only going to graph the side that where x is greater than or equal to 0. And when I do that, well, it passes the horizontal line test. It only will cross one point at a time. So I'm going to say the function passes, or the inverse of f is a function because it passes the horizontal line test. So now we actually need to find what the function is. So I'm going to write f of x is equal to x squared plus 2, and I'm going to remember that the domain is restricted. X needs to be greater than or equal to 2. But more than that, there's also a restriction on the range. The range is going to be where y needs to be greater than or equal to 2. But the most important part is x needs to be greater than or equal to 0. Okay, so let's go ahead and look at this. So we have y, so I'm going to replace f of x with y, and we have y is equal to x squared plus 2. And I'm going to switch the x and the y values. Now notice that there was a restriction on y, so that's going to come up in a little bit different, or a little bit later. So I'm going to write x is equal to y squared plus 2. Now I'm going to solve for y by subtracting 2 on both sides, and I have x minus 2 is equal to y squared. I'm going to take the square root of both sides, and I end up with plus or minus the square root of x minus 2 is equal to y. Now it's plus or minus because there's two sides of any quadratic, and when you take the square root of both sides, you have two answers. Excuse me. So which side are we going to use? Well, the side where x is greater than or equal to 0, that's all positive numbers. So we're going to use the positive version. So we have y is going to be equal to the positive square root of x minus 2. So that means that we have the inverse of x is equal to the square root of x minus 2. Now, we had before that x needs to be greater than or equal to 0. But our problem is that if we were to plug 0 in, well, then we would have a negative underneath the root, and that's not real. So instead, we need to identify what value of x would make this equal to 0. And that's where the y is greater than or equal to 2 comes in, where our range comes in. So in this case, our inverse is f of x is equal to the square root, or the square root of x minus 2, as long as x is greater than or equal to 2. The most important thing that I need you guys to come up from this is the inverse. We can certainly talk about the restriction on any sort of domain of the inverse later on, but the most important thing is, can you identify the inverse? That is the end of this lesson. It was a little bit longer of a lesson, but if you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.